So did everybody grab a pencil for this today so that if you make a mistake, you can not scribble all over your notes? There's some up here if you need one, okay? Is sine x or y, guys? What have we learned from our unit circle? The sine function is the y value. So if we look at this interactive unit circle website here, that's not my favorite. Let's try the other one. Let's try this one, see if it looks any better. So this goes super fast in my opinion, but the red value is the height. Do you see the red goes up and down, guys? Okay. So that is graphing the height as it changes going around the unit circle. So that's what we're going to do a little slower. So if I start right here at 0 degrees of rotation or 0 radians, this is worksheet, yes, 11. Does that sound right? Or is it 10? 11? Okay. So there's no height there. It's at 0. If I move over here, it gets a little bit taller. If I rotate around to up here, it's now this much in height. If I rotate around to here. So is the height increasing or decreasing? Increasing, yes. Okay. And is it positive or negative? Okay. Do you remember what a unit circle meant? What did the word unit mean? Meant the radius was 1 unit or 1, okay? So this ordered pair up here has a length of how long? That distance should be 1. Okay, so what we're going to do, and I'm really bad at this, so I'm going to use the smartboard to cheat. We're going to take, as we went around, those got longer and longer and longer, okay? So what I'm going to try to do, if it works, is take those, copy them, paste them somewhere, and flip them because they got to be going, as we went around, it was increasing, okay? So, yeah, let me scooch that over. That'll look a little better, okay. The next, as we continue to circle around, what's happening here? Are these heights positive or negative? The y value right here, guys. Positive, okay? Increasing or decreasing? As I go around, they get shorter, right? Okay. So if I take and look at these that I just drew, of course it's not going to give me all of them. All right, I'll just try to draw them. I'm not good at this, but they're getting shorter. But they're still positive. Okay. When we get down into this quadrant, we got all the way to 0. And now as we go down this way, so I pick a spot, I'm right here. What is the y value? Very short, yes? Positive or negative though? Guys, y values. Am I going up or down in that quadrant? The y's are down, so they're negative, Miss Hoffbauer. Is anybody awake out there? Okay. So all of those we're getting more and more negative. Okay. And then as we got over to here, if I rotate around on my unit circle to here somewhere, they're still going negative, but what's happening? Ever so slowly, they're getting what? Shorter? Everybody see that? Okay. So that little chunk, whoa, just kidding. If we copy them over to here, we end up with a shape so that the y value, as we travel around the unit circle, the y value goes up and it comes back down, and then it becomes negative and it comes back to 0. Okay, mine is not drawn well, but I tried to make it copy from the unit circle over here. All right, we took all the way around one time to draw that. So all the way around is how many radians? Okay, so to here is 2 pi. Now, if we start around again, what is going to happen to that shape? It's going to repeat, yes? Or if I had gone the other direction as I rotated, it would repeat, okay? This graph does not end. As you keep rotating around, the graph will repeat. Now, it's a little hard to see from the way, by the way, if that's 2 pi, this would be 1 pi, right? Halfway here. What's halfway to there, guys? Half of pi would be pi over 2. And it went up to 1 and down to -1 because that's the radius. All right. But going back and looking at this, if I were to draw the positive branch over here and the negative branch over here, what is the symmetry of that? Do you remember? X-axis, Y-axis, origin. Yes, it is origin symmetry, which makes it an even or an odd function. It's an odd function because it has origin symmetry. Now, unfortunately, or fortunately, anyway, not all sine graphs have origin symmetry. The normal sine, but if you stretch it up and down, good. Stretch it left and right, still will have symmetry. But as soon as you start shifting the whole thing up or down, it doesn't go through the origin anymore, or shifting it left or right, it will not be an odd function anymore. All right, this one, if I go back to the website real quick, and we go down here and we look at the green, no, the purple, kidding, the purple. Do you see if we start right here as the purple goes around, it's going horizontally, yes? It's measuring the X value, okay? So I'll try to go a little faster this time, but when you start here, this has a X value of what if it's a unit circle, guys? That's 1, 0, right? So when you translate it over here, it's going to go up to 1. All right, so we had 1, 0. And then as you rotate around, what happens to the X values? They get shorter or smaller until they get to 0, right? The ordered pair up here has the 0 for the X value. If we, whoa, just kidding. If we copy those, okay, and then I go back over here, and what happens over here? The X becomes what? As you go left, what is happening, guys? Okay, it's getting longer, but it's also getting what? Negative, okay? And it gets all the way to -1. What's happening here? I need to... Nope. This was a really bad plan, wasn't it? Because I don't know what I'm doing. That's the way I need the shape to go, but why did I need to turn it? Oops. Oh, I think I was supposed to, anyway, I'm just going to keep going. I think I was supposed to turn that one too, because, no, it's X's. All right, this is still negative, but it's getting shorter. This is still negative, but it's getting shorter. Whoops. Then what happens in this quadrant? It's getting longer, but it's getting more and more positive. So we get up to here, and it starts getting longer again. Okay. So I didn't do a good job, but this is what it's supposed to be doing. I did that first one wrong, I think. All right. So all the way around took until 2 pi, but this time it did not start at the origin. Anybody know what we'd call that point up there? What do we call the peak of a graph? We learned when we were doing graph analysis. Yep, this is a maximum, and the next maximum occurs 2 pi later, okay? Until we do some shifting, and it goes down to -1. Now, it does continue infinitely. It will repeat this pattern. So if I look at just the little chunk right here, oh, my graph is not good at all, but what kind of symmetry does that have? Y-axis symmetry, which makes it an even function. All right, I spent way too much time doing that. So a sine graph has to go through the origin, guys, whereas a cosine graph, these will all go through the origin today because they're not shifted left, right, or up, down. The cosine graph will start at its maximum. A better way to describe the sine graph is that we'll start at the midline and then go up and then down and end at the midline when it's done one period. Okay, the cosine starts at its maximum, goes to the minimum, and goes back to its maximum. Notice that the cosine function is just a horizontal translation. So look what happens. If I take this and I slide it left or right, do you see that it matches up with the cosine, or the other way is also true? If I take this cosine and I slide it over here, it would fit on top of a sine, okay? So they are really just translations left or right of each other. One more vocabulary word. It says sine and cosine, since they're really based on the same shape, are both called sinusoidal functions. So if you see the word sinusoidal, it does not mean it has to be a sine or a cosine. It can be either one. Please be paying attention. Amplitude is half the distance between the max and the min. You have this here, I think. It says half the distance between the minimum and maximum values, okay? Can you write that? Don't you have this somewhere? Okay. What does this mean? Which makes it what kind of a number? Positive. So the amplitude is always positive. What in that definition tells you it's going to be a positive number? Do we have negative distances? Okay. Distance is always a positive number. So when you're looking at the graph, no matter what the graph looks like, okay, the amplitude is this height from the midline to the maximum, which should be the same as from the midline to the minimum. Even if we were to take and shift the graph up here, okay, from the midline to the top is the amplitude, or from the midline to the bottom is an amplitude. if it's easier just, you know, to go back to this graph and write, this is how you measure amplitude, you certainly can write it on there. All right, the next thing is period. The period of a sinusoidal function is the distance between two sets of repeating points on the graph. Now, please notice if you start here, you don't finish here. Do you understand that that's only half a period because you didn't do both parts? You didn't do the below and above, okay? But if you start here and you've done the entire cycle and it finishes here, that distance is 1 period. So it says the length of a cycle can start at any point on the graph. Did you already copy that one down, guys? Okay, this is 2 pi over b. It is a reciprocal relationship. Let me just review that for a second with you. This is how we learned it first semester. What was A? It was a vertical stretch. Remember that? Or shrink? If it was a 2, it stretched it. If it was a 1/2, it shrunk it. Sound right? But what happened when we put it, do you see where the B is in here? It says cosine bx. What happened when we put the B inside the parenthesis? Do you remember that nightmare? It changed the graph horizontally, and it was the opposite of what it seemed. It was a reciprocal relationship. Do you remember, like, it would shrink it by 1 over b or stretch it by the reciprocal. If it was a 1/2, it would stretch it by 2. Okay, so this is what it does when you have a cosine or sine function. The normal period is 2 pi, and you will divide by b. I'm not worried about the absolute value because I'm never going to give you one with a negative b value. Deal? All right, I'm going to go to this slide, and we're going to write y equals sine of x. We're going to plot real quick. It starts at 0, 0. It finishes at 2 pi. It goes up through the middle and then down. And the amplitude is only 1 on a normal graph, so we'd have ordered pairs at 0, 0. We'd have pi over 2. It would be up at 1. Pi, it would be back at 0. 3 pi over 2, it would be down at -1. At 2 pi, it would be back at 0. You can graph this way. You certainly don't have to write any ordered pairs over here. It repeats. It just keeps going. Okay, if there are arrows left and right, what is the domain? Left to right. Yeah, all real numbers. It doesn't stop. It goes left to right forever. Max and min, what is the minimum y value? Smallest y value. Guys, you're scaring me. What's the smallest y value right here? -1. The top y value was 1. Okay. Now, it's hard to identify an x-intercept because there's a lot of them, right? And it's going to keep happening. What's an easy one? 1 through 0, 0, yes? And the next one is how far over? Pi to the left or pi to the right. So you can keep adding pi n times where n is an integer. We talked about this briefly one day. N is an integer means you can add pi -2 times, -1 times, 0 times, 1 times, 2 times, etc., etc. So if I said 7 pi, would that be an x-intercept? Yes, as long as this is your period, it's going 2 pi, but it's hitting the x-intercept every pi. All right, where does it cross the y, guys? It only crosses the y once at 0, 0. It has no asymptotes. The amplitude, okay, is 1. It goes above and below the midline by 1, and it took an entire length of 2 pi to finish. We are today going to talk more about amplitude. in this equation, A sine B x minus h plus k. And we're going to talk about what B does. It's going to be 2 pi divided by B will be the new period. Now, H is going to shift it left or right, and K is going to shift it up or down. I'm not really worried about those today, so I'm not going to take time to write out all the words like they did in the little notes over there. Okay, those of you who just came out of Trig, I apologize. I'm sure you're bored out of your mind. Does some of you like overwhelmed because you don't remember this at all? Or do you remember it from last year in Honors Algebra 2? Nobody's saying anything. Okay. Cosine, what was the difference with cosine, guys? It's exactly the same except it started where? At the maximum. So it starts here, and it does not go back there until pi. 2 pi, sorry. Halfway in between, it's at the minimum. So it's crossing the x-axis at pi over 2. I won't write all the ordered pairs this time, but it does cross over here again at 3 pi over 2. This was 0, 1. And it would continue. Okay, quickly, left to right. Does it end? So it's all real numbers. The range, bottom to top. -1 to 1, thank you. X-intercept, where does it cross the x-axis? Just give me one spot. Pi over 2. Okay, how far is it till it crosses again? Anybody know how far apart those are? Yeah. It actually, from 1 pi over 2 to 3 pi over 2 is 2 pi over 2s, which would be 1 pi. So it crosses every pi. Probably not a quiz question. Okay, where did it cross the y-axis at? 0, 1. It has no asymptotes. Its amplitude is 1 and its period is 2 pi. Until we start doing some junk and throwing letters or other numbers in here. Okay, amplitude is the absolute value of A, and the period is 2 pi divided by B. It's a reciprocal relationship. And it started at 2 pi, and that's why it's being stretched or shrunk based on 2 pi. Plus or minus h would shift it left or right, and plus or minus k would shift it up or down, but we're not going to worry about those today. Before I forget, what does this do out in front? It does not affect amplitude at all. Do you remember what it did last time? It is a reflection over what? X-axis. Do I have any time left? All right. You are not going to have to graph these by hand. You're going to do some delta math tonight. This is a B of 1/3. Just watch for 1 second, guys. If you are supposed to divide this by 1/3, that means you're really taking 2 pi and multiplying by 3 over 1. So the period would become 6 pi. So it's a sine graph. It's finishing half a period by 6 pi. It doesn't finish a whole period till it gets out to 6 pi out here, which mine is stretched too far. All right, we will spend a lot more time doing this stuff next week, but the delta math is a little bit different. It does some trial and error. It asks you to identify a period. So please just work on the short assignment called Trig graphing part 1.